Okay, Sumit, welcome to this session on linear algebra. This is for beginners. We may have a couple of people joining, but irrespective of who joins, let's start the session. Okay, over to you.
Yeah. Oh, yeah. Thank you. So, I am preparing linear algebra for my GATE exam, and when I first heard this subject, I had a confusion. Why linear algebra? What is so special about linear algebra? So, by the way, just to let everyone know, what is linear algebra basically? Linear algebra is uh, linear algebra is used to solve quadratic equations. Equations basically, the equation of form x plus y equal to something, x square plus y equal to something like this. The variables come into picture. So this is where linear algebra is used. And what is the use of linear algebra in the field of computer science or in the field of machine learning basically? So all our computation that we do is some kind of computation operation itself. So we do a lot of operations such as matrix operation, or be it, or we are trying to solve some distance problem, any type of mathematical equations involve linear algebra. So now we study linear algebra for one specific reason, in order to reduce computational cost and try to increase speed of solving. That's where matrix, different types of formulas, linear algebra formulas to solve the equations very easily. All this come into picture. This is the like whole glimpse of linear algebra and why people study linear algebra. It is basically to reduce computational cost and increase speed of computation in the field of computer science. I hope this is I hope it is clear. This is why computer science engineers are taught linear algebra subject basically.
So linear
I hope it is
algebra
clear.
is linear algebra a, a one what you call subject in mathematics?
Yes,
So
it's a one subject in
is it
mathematics.
usually taught by the mathematics teachers or by computer science teachers? Mm.
It is a mathematical subject. It's a
Mm.
very big subject, but there are few aspects of linear algebra that every engineer must know. As I said, it helps us to solve systems of linear equations. So there will be in computation, there will be hundreds of equations, and at that time, having the knowledge of linear algebra makes it easy for us to solve few of the problems in a less computational heavy and increase the speed up basically. We
Okay.
can say it like that.
Okay. Proceed.
Now, in order to understand linear algebra better, we have to understand matrix first. So I think Vishank is here. Can you explain what matrix is? If you're comfortable, can you say what matrix is?
Okay, so according to me, matrix is like two-dimensional space where numbers can be stored. So it represents both x and y coordinates.
Yes. So matrix is x and x into y dimension of number stored. So there will be x rows and y columns, and there will be content. One. So these are called as rows. These are called as columns, basically. So now this matrix is heavily used to solve system of linear equations. As I said, linear algebra does not deal with individual equation, not x plus y. It also deals with set of equations like this. So now instead of linear algebra makes it easy for us to solve these equations together. For example, now so this is where now I can represent these equations in the form of matrix, and so I can then solve these equations. That is why we use matrix in linear algebra. So now let us understand matrix in matrix easily one by one. So basically, matrix is a way of storing numbers in m cross n manner. Okay. So there are two types of matrix. One is square matrix, other are non-square matrix. Okay, just dividing it here. There are a few other types of matrix which will come down eventually. So what is the difference between square matrix and non-square matrix? In square matrix, number of rows will be equal to number of columns. In a non-square matrix, number of rows will not be equal to number of columns. Okay, I hope it is clear.
Yes.
Yeah. So let us ignore non-square matrix for now, and let us come to square matrix, as there are a lot of things that we can do using a square matrix. Okay. Now, what are the operations that we can do on a square matrix? So first thing, we can find transpose of a matrix. Okay. Transpose. I'll just write down few points. We can find transpose, inverse, and we can do whole lot of operations on this. Then the operations include projection. We can do projection, orthogonal projection. We can find normality. We can try to solve these big equation by dividing it into smaller equations. So we'll come to all those one by one, but let us now start with fundamentals. What is a transpose of a matrix? Anyone, any idea here? What is a transpose of a matrix? Anyone? I think Ankita is here. Ankita, would you like to try what a transpose of a matrix is?
Where the number of rows and columns are interchanged?
Yes. So basically, in transpose, we interchange the rows and columns. A new matrix is created by swapping the rows. For example, if we have A, and A matrix has A11, A12, 22, and we can carry out A transpose. Okay, A transpose matrix will have A11, A21. You can see we are converting this column into a row here, basically. I hope you are getting it. And then subsequently this row into this column into a row. I hope you all got it.
Yeah.
Okay. Now, when we do this operation, there can be three types of matrix. Okay. One is in when A equal to A transpose. Such matrix are called as symmetric matrix. Okay. There can be also a case where A transpose equal to minus A. That will be skew symmetric matrix. Okay. These are all, I think you can all keep this in mind. Eventually, when we come to the topic of discussion, we will come to these topics. Anyways, I hope you get it, right? So these are the two types of matrix that can be found, and there are also matrix where A will be not equal to A will be not equal to A transpose at all. Okay, these are basically three types of matrix that exist when we do transpose of the matrix. Okay. Now let us talk about determinant of a matrix. So anyone, what is the determinant of a matrix? Anyone?
There is a certain formula to find out the determinant. I am aware of that.
Yes.
But I don't know the
So basically,
exact
determinant of
definition
a
of a
matrix
determinant.
is a scalar value of a square matrix. So determinant can be only found for a square matrix, basically. So we can find determinant only for n cross n matrix, where both row is equal to number of columns. Okay, and determinant helps to find a scalar value of that matrix. How do we do this? So for 2 cos 2 matrix, we find determinant like something like this. So there exists a matrix A, B, C, D. Then determinant of this matrix is equal to, you multiply these two, you multiply these two. So basically A into D minus C into B. Okay. So basically it helps us to find the scalar value of a matrix. I hope it is clear to you. Okay.
Yeah. So
Now this is for 2 cross 2 matrix.
what is the definition of a scalar value? Is a single computed value.
Single
right?
value of a matrix.
Okay.
Singular value of a matrix basically. Okay. Now let us 1 second. Yeah. So now let us go for 3 cross 3 matrix. So 3 cross 3 matrix will be of something form like this: A, B, C, D, E, F, G, H, I. Okay. Now, in case of a 3 cross 3 matrix, the complexity increases. So now if I have a matrix like 6, for determinant, I have to write, I have to take first row. Okay, first let us, you can take any row, by the way. You can take the middle row, you can take the first row. But for ease of use, we'll go from the first row. So I'll take the first row. If I take A, then I have to do like this. So then this is then similar to what we did in the square matrix. You have to multiply these two and subtract it. So EI minus FH. Okay. I hope you got it. Now, 1 second. Now subsequently we'll do for B. Again for B, you ignore these two. You write B DI minus F into G. Okay. And similarly, you do for C, you remove these DH into GE. And then you add all those. Okay. Now
it is DH minus EG or plus EG?
DH minus EG.
Okay.
So in order to understand this better, let us go to one more aspect which I thought we would not touch upon. But anyways, since there are confusions here, so basically before finding determinant, let us understand what is a cofactor of a matrix. There is something called as cofactor. Okay, cofactor. So there is something called cofactor, which can be represented as Cij equal to, let C is a matrix here, Cij equal to minus 1 I plus j into Mij. Okay, this is the formula for a cofactor of a matrix, and determinant is related to cofactor such that determinant is equal to Aij into Cij. Okay, this is the relation between cofactor and determinant. You don't look into the formula. I know it looks like very weird, but I will make sure you guys understand it very clearly. Okay. Now, what is the Cij? So Cij, let me go back to this. So now for every matrix, we can find a cofactor of that matrix, basically. And determinant is the sum of all the cofactors. Okay. So what is a cofactor basically? So initially, cofactor is a cofactor for A. For example, I have A. What is the cofactor of A? Cofactor of A is nothing but determinant of the when I remove, if I select A, I have to remove its row and its column. Then whatever is remaining, we find its determinant, and then we multiply it with minus 1 to the power ij, I plus j. Okay. Now, what is this I plus j? Basically, in a 3 cross 3 matrix, what is this position? Anyone? Where is A located at here?
Zero,
in a matrix 3 cross 3.
0, 0.
0, 0, but we consider it as 1, 1.
Okay.
In mathematics, we consider it as 1, 1. Okay, so it's 1, 1. Minus 1 to the power 1 plus 1. That becomes, what does it become? It becomes 1 square, that is 1. So, while finding determinant, while finding equation of determinant, 1 second, we keep first positive. now coming to the second B, what would be the position of B in the same cofactor? If you calculate cofactor, so basically cofactor of B would be, if I do this, D F
1, comma
G
2.
H. 1, comma 2. 1, comma 2 is basically an odd number. That's why it will be minus. So here it will be, 1 second. Let me make it clear. So this is plus 1. This is minus 1, and subsequently it will be. This will be anyone? It will be plus, because again, if we add two odd numbers, it will be even. So square of minus 1 to the power any even number, it will be plus. Similarly, if we go to the next row, it will be minus, this will be plus, this will be minus, again plus, minus, plus. If I write it clearly, in a matrix, this is the trend of cofactor in a matrix. Okay. Now we use these symbols along with the elements here. So example A, B, C, and find determinant of the matrix. Determinant. So while writing determinant, what I do is I'll see. I'll remember whether it's positive or negative. So I'll write plus A into, what is the cofactor of this A? So basically, when we one second. Okay, so I hope now when I find determinant of this man, I'll get C I minus H, and what is this? F, FH minus B D I minus H and F. Oh, not H and F, by my G and what is this? F. Okay, 1 second. F. G and F. Then again plus C into what is this? D and H. Both are negative, so it will be plus. So DH and 1 second. When I remove these two, it will be DH minus GC. Okay. So this is what the equation will lead us to. This is the determinant of 3 cross 3 matrix. Similarly, you can find for any n cross n matrix. Okay. I hope it is clear now. I tried my level best, but basically it's a formula. You can memorize that formula.
Okay.
Now, I hope determinant is clear. Anyone would like to repeat what determinant is basically?
If you can,
if you guys are
if
interested,
you can show the matrix, I can tell you what the determinant.
Okay, so now let us, for example, I hope you all have paper and pen. Let us find determinant of this matrix.
Okay.
Can you all try it out?
Can I try? 1 into
Yeah, sure.
21 minus 24 plus 1 into 14 minus 20 plus 1 into 12 minus 15. (21 minus 25 plus 1 into 14 minus 20 plus 1 into 12 minus 15, that is minus 4 minus 6 minus 3 minus 13.
I think there is some mistake.
Wait, 1 into
determinant is 0.
Wait, 1 into 21 minus 25 is correct? 21 minus
No.
28.
So
21 minus 28. No, 21 minus 24, correct.
okay, let us do one thing. We will try to solve it ourselves here once,
Okay.
and let us see where we went wrong. So all these are one value basically. So I'll just directly jump few steps. So I have to find determinant of 3, 4, 6, 7 plus I have to find 2, 4, 5, 7 and 2, 3, 5, 6. Okay, these are the determinant I have to find. All will be multiplied by 1. Okay, am I right? Sorry, my bad. Give me a second.
Correct.
This should be minus. Okay,
Which one?
this value. So this is plus, this is minus, this is plus.
Oh.
Okay.
Okay.
Now, what will this lead us to? What is the determinant of this? So I know the determinant. It will be minus 3. Okay. And then what will be the determinant of this? This will be minus 6. Yeah, thank you. And the last one, it would be minus 3.
-3.
So now, minus minus is plus, minus 3 plus 6 minus 3. So this all cancels to become 0. So this becomes determinant equal to 0. I hope you all understood how to find determinant now, basically.
Yes.
Okay. Yeah. Now let us move further. Now let us try to understand. I think determinant is done. Now let us try to understand what is an adjacent of a matrix. If there is a matrix A, what is adjacent of matrix A? Let us try to understand this. Does anyone here know what adjacent of a matrix is?
No.
It is basically transpose of its cofactor matrix. Okay. I think it will sound very odd, but once we do that, we will understand what adjacent of matrix is. Okay. So now adjacent of matrix is adjacent of A is equal to, it is transpose of cofactor of the matrix, basically. And by the way, I also mentioned about the formula for cofactor of A. Can anyone repeat the formula? I just mentioned it a few minutes back. So cofactor of matrix. Okay, cofactor of matrix is basically -1 all to the power I plus j. Okay.
What is the second term? -1 to the power I plus j. After that, what you wrote, I didn't understand.
Mij is basically determinant of that square matrix that is left.
M is a short form for determinant, is it? Okay.
No. M is a, I mean, if there is a bigger matrix A, if A is a 3 cross 3 matrix, I represent this matrix as a M matrix.
Okay.
Okay.
No, this between these two, is it a multiplication?
Sorry. Yes, this is a multiplication. -1 into.
Okay.
But we do not represent with multiplication symbol because there are two types of multiples that is possible here. So anyways,
Understand.
so basically this is the cofactor adjacent of a matrix and cofactor of a matrix. Okay. Now I think it will take a lot of time if you find adjacent of a matrix. If you try to solve adjacent of a matrix, basically, so you have to find adjacent of a matrix. If a given matrix is A, B, C, D, E, F, G, H, I. So basically, we have to find this value first. Have to place this in this matrix here. Then for here, we have to again find determinant of this matrix. So it will take a lot of steps, basically. Do you want me to proceed with the steps, or let us move to the next topic?
Yeah, we can move to the next topic.
Okay. So now, adjacent of matrix. Just a question here. What do you think adjacent of a square matrix would be? of order 2. I mean, what would be the adjacent of matrix 2 cross 2? How will you find the cofactor here?
Sorry.
Sorry, adjoint of a matrix. How will you find adjoint of
Are you
2
talking,
cross 2 matrix?
are you using the word adjacent or adjoint?
Yeah, my bad, my bad. It was
It should be
supposed to be
adjoint. Huh?
yeah, adjoint. I'm really sorry.
Okay.
It was adjoint. I think I forgot. Sorry, my bad. So it was supposed to be adjoint. Okay. Anyways, so adjoint of 2 cross 2 matrix. I said for 3 cross 2 matrix you will find cofactor, and I gave you the formula for cofactor. But how will you calculate cofactor of 2 cross 2 matrix? I think it's very easy if you think. You can try it. I mean,
No, please show it to us.
okay then. Okay, I will do it. So let us consider a matrix of 1 cross 1. Okay. Now let us try to find adjacent of this matrix. How will we do this?
Let's try to find adjoint of this matrix.
Yeah, adjoint of the matrix. So if I go back to the formula, Cij Cij equal to -1 I plus j equal to mij, basically, right? Now, what is the m for this matrix? If I delete this, the m is this one, right? So m11 is basically 1 itself. 1 into, what is this factor? -1 to the power I plus j. So 1 plus 1 is 2. 2 means square, so it will be positive. So I will not multiply, it will be 1. M11 is 1. So what is M21? M21 means, okay, for each matrix we'll draw it once again. 1, 1, 1, 1. What is M21 basically? M2 is row 2, this matrix. So after remove this, this is 1. 2, 1. 2 plus 1 is 3. So basically 2, it should be -1, I believe. Am I right?
Yes. -1 to the
Yes.
power of 5, right?
Yes. No. -1 to the power 2 plus 1 is 3, sir.
2 plus 1. -1 to the power of
3
3.
-1.
Yeah.
Then M12. M12 is, what is M12? This is M12. So we cancel out this. The left is this part. M12, 1 plus 2 is 3. So it will again be negative. And at last there will be M22. M22 is positive, and its value will be 1. So basically we got the final matrix, cofactor matrix. C of matrix of A equal to 1 minus 1 minus 1 1. Okay. Now let us try to find the adjoint of this matrix. So adjoint of this matrix transpose.
Wait, cofactor of a matrix is another matrix, is it?
Yeah. Cofactor of matrix, as I said, I gave you the formula. It helps to find out the individual values here.
Yeah.
So now
Adjoint
adjoint of a matrix
is
is
also another matrix, is it?
yeah, it's another matrix.
Okay.
So adjoint of matrix is nothing but cofactor transpose. I hope we understood what transpose is.
Yeah.
So transpose is just in reverse the rows and columns. So it will be -1 -1 1.
But in
This is
this
adjoint
case,
of a matrix.
cofactor and adjoint happens to be same.
In this case, it happen to be same, but it may not be same. So we have finally got the adjoint of a matrix. Okay. Now what is the use of this adjoint? Adjoint helps us to find something called as inverse of a matrix. Okay. Inverse. What is this inverse? Any matrix A can be converted into in a form of A inverse if its determinant is not equal to 0. Determinant is not equal to 0 basically. I hope you get it. Okay, any matrix can be converted into inverse of the matrix, provided that determinant must not be equal to 0. I hope it is clear to you guys.
Okay.
So what is this use of this inverse of a matrix? When we come down to linear algebra, we'll come to know the importance of such inverses. All these things helps us to solve the equations quickly. That's it. Okay. In some or the other way, it helps us to solve the linear algebra much more easier. So now let us understand inverse of a matrix. So A inverse is given by the formula 1 by determinant of A into adjoint of the matrix A. Okay. I hope.
Is this the standard formula? A inverse is
Yes.
1 by
Yes. This is standard formula
So
for
1 by
inverse of a
determinant of
matrix.
1 by determinant of A is a scalar value, right?
Huh. Into adjoint of A. Okay.
So each of the items of adjoint of A will have to get multiplied with this first factor.
Determinant of A. Yes, sir. Yes.
Okay.
In order to find inverse of the matrix.
Okay.
Now, what is the? I mean, A inverse. What do I mean by A inverse? Basically, if you think like that, let us. If you think like that, in mathematics, what happens if I multiply 3 into 3 inverse? Basically,
1. 3 into 1 by 3 is 1, right?
yes. Similarly, if I multiply A into A inverse, it will lead to
Unity matrix.
yeah. In general, it will lead to a matrix called I.
Okay.
1 second. Okay. Now, lot of operations that are similar to mathematics can be done on the matrix. Okay. Something like 3 inverse into its inverse. What is this? What is 3 inverse into 3 inverse? It's okay. Let's ignore this now. So basically, you remember this: A into A inverse will give us I. I is identity matrix. What is identity matrix? I is equal to what is an identity matrix basically? Anyone?
1, 1,
Anyone wants
1,
to try
1.
what identity matrix is?
1, 1, 1, 1. All numbers, all elements are 1. No?
Yes. So identity matrix is not exactly all are one. All diagonal elements are one, and rest are like this.
Okay.
This is called identity matrix. Okay. So identity matrix is of this form where diagonal elements are one. Let me write it clearly. I equal to 1. This is an identity matrix basically, guys. So what is the use of an identity matrix? What is the specialty of identity matrix basically? So if you multiply any number with I, it will give I back. Sorry, A back. Okay. So if I multiply matrix A with I, it will give me A back itself. This is identity matrix. And A inverse helps us to find the identity matrix if it exists. Okay. Now, not all matrices will have an inverse. Not all matrix will have its inverse. Okay. Why? Why? Can anyone answer? Okay. Let us go back to the formula.
Whenever the determinant is 0, inverse doesn't exist, I think.
Yeah. Why basically?
Because 1 by determinant will be infinity.
Yes. It will cause a computational error. Infinity. I mean, it does not exist. So hence, for determinant, in order to find inverse, we have to have determinant that is not equal to 0. I hope it is clear. I hope it is clear, guys. So traditionally, why do you do all this operation? You might think, or why should I find inverse? Why should I find transpose? So basically, in linear algebra, especially in matrix, all these are existing just to convert a matrix from dense to sparse matrix. Okay, will be of form A, B, C, D, whereas sparse matrix will have CD. You can see, let it be 0. So you can see number of 0 increases. Dense means all the values in elements inside the matrix has some value, whereas in sparse generally more number of elements will be 0. If it is 0, the computation is easier. Okay, so we convert a dense matrix into sparse matrix without affecting the outcome. Okay, I hope it is clear. We try to convert a matrix into 0 form, I mean majority of the element to be 0, while making sure that the equation does not fail, or the, the data is not tallied. Because if you think like that, A, B, C, D, I'll multiply this entire matrix with 0 matrix. Now we got all 0. This is of no use for us. So we convert A, B, C, D, a dense matrix into a sparse, while making sure that we return as much as possible, so that we have to find solution basically. I hope you are clear on why we are converting A inverse, why we are finding all this, right?
Okay, proceed. No, proceed. We might understand as you proceed.
Okay, if not, I think we can try to solve all this here only. Do you want me to solve, or
No, you proceed. Let's try to
okay.
understand the whole topic once, and then we can.
Yeah. Okay. Now, as I said, there are two types of matrix basically at the start, which was a lie. There are some other forms of matrix. So now let us try to understand these matrices one by one. There is something called as row matrix. Row matrix is basically A, where we have only a row. This is a row matrix. What is a column matrix then? Anyone? What would be a column matrix?
Single column, A, B, C, one below the other. Yeah.
Okay. Then what is square matrix? I think square matrix we came to know by now. What is a square matrix?
Number of rows is equal to number of columns.
Yes, m equal to n. So basically, A, B, C, D, or a 3x3 matrix. Basically, I will not write the content here. Now there are other forms of matrix such as zero matrix. What is zero matrix?
Diagonal elements are 0.
Yes, zero matrix is a matrix with all elements are 0, not just diagonal. All elements are 0. That is called a zero matrix. Okay. Now, next is identity matrix. What is an identity matrix? I.
Diagonal elements are 1.
Yes. Diagonal elements are 1. Next, there are something called diagonal matrix. Diagonal. What is diagonal matrix? Anyone? Diagonal matrix. Only diagonal element exists. Rest all are 0. Okay. I hope it is clear.
Okay.
Now there is something called upper triangular. Upper triangular. Lower triangular. Now what is upper triangular matrix? I think it is now. I think it is very easy.
Above
The
diagonal, everything else is non-zero.
Yes. So an upper triangle matrix will have like this, and subsequently lower triangular matrix would be. You can see this is a diagonal. Above the diagonal, all elements have some value. Below it, all are 0. In lower triangle, it is reverse. lower it will have value, but upper it will not have value. Okay. I hope it is clear now. Right. Then we found out square of a how do we find the trace? How do we find transpose of a matrix? How do we find adjoint of a matrix? How do you find inverse of a matrix? How do you find cofactor? How do you find determinant? Right. Now let us understand one more concept called as trace.
Sumit, there's a question in chat.
Okay.
Matrix containing all elements equal to 1. Is it called unity matrix?
Unity matrix.
Matrix containing all elements equal to 1. What is it called?
So I mean, 1 second. So all elements equal to 1. You meant 1 1 1 1 or 1 1 1 1 1 1.
Correct.
Yes, we call it yes, basically yes, yeah. We call it as unity matrix. Yes, correct. Unity matrix or matrix of all ones. So yes, you are right, Shrestha.
Okay.
Okay. Now, but generally such matrix are not. I mean, up till my study, whatever I have done, we do not use this explicitly for any of our use case. Okay, but be it zero matrix, be it upper triangular, lower triangle, we use it frequently during whenever we are trying to solve our equation. Okay, so let's come back to the trace topic. So what is trace? What is trace? Anyone like to answer?
No, not aware.
Anyone? Shrestha, you can give a try. Vishank, I think Vishak has been answering answers. So Shrestha, you can give a try. Come on, guys. Okay, so trace is basically sum of all the diagonal elements. Okay, sum of diagonal elements is trace of a matrix. Okay, I hope it is clear. Equal to trace. Okay, is it clear what a trace of a matrix is?
So trace is a scalar value.
Yes, trace is a scalar value. It is sum of all the diagonal elements.
Okay.
Yeah. Okay. Now let us understand powers of a matrix. What is a to the power 0? It is just like saying 1 to the power, sorry, 2 to the power 0. What is 2 to the power 0? Anyone? Yes.
1.
So what will be the a to the power 0? Matrix to the power of 0.
1.
Identity matrix.
Identity matrix. Okay.
Yes. Then what would be the matrix is a to the power 2? A to the power 1, sorry. A to the power 1 would be a. A to the power 2 would be a into a. Okay, like this. I hope you understood power of a matrix. There is no difference than a normal number. Okay, both are quite similar. Now let us understand polynomial of a matrix. Okay, so basically what is a polynomial? Anyone? What is a polynomial?
An expression containing multiple factors of a variable.
Yes. So x square like this. Such are called as polynomial. Okay. A value. That's it. That's the whole difference between a polynomial matrix and polynomials of a matrix and a normal matrix. So instead of x, there will be a. So what would be the equation now? F of a would be equal to a is naught. So a naught in a normal equation it's supposed to be multiplied by 1, right? Right. So here a naught will be multiplied by what? identity matrix plus a1 into x instead of a1 a then plus ai square a to the power square and so on basically. Okay, 1 second. Yes, so this is what a polynomial of a matrix is basically. I hope you got it. Any doubt till here? If you guys have any doubt, please let me know. Because this is very impromptu that I'm doing. I mean, whatever I'm like, I'm trying to share it with you guys. So, if you have any doubt at any moment, please let me know. I will try my level best. I hope everything is clear till now.
It's okay, Sumit. Proceed. We have another 15 minutes left. Okay.
Okay, I think in that case, since we have very small amount of time left, let us do one thing then. Let me try. Let us discuss. Let me just give out the resource at the start itself, so that you guys can learn yourself if you want. And then with the remaining time, we'll try to teach as much as possible. So you can see there is some tab that I have opened here. So this tab is of YouTube channel that I found, and I would like you all to go subscribe to this channel and support the channel. This is not my channel, so but in my journey, this channel has helped me a lot. Okay, so in my journey, this channel has helped me a lot. So there are a lot of lectures that has been uploaded here. You can see related to mathematics, and there are some beautiful textbook this guy has made. So you can see syllabus here. So there are textbooks available which you can download. Now I will be sharing my video screen. 1 second. So you can see these are the textbooks. I'd always like to keep a physical copy of the books and then make cheat sheets. These are the cheat sheets for formulas. Basically, you can see I have maintained all the formulas. You can see generally mathematics. It is very nice if you all start by writing. So it will be very helpful to you guys. So, anyways, this was the YouTube channel. You can see all the lectures are taught very well. So this is where I learned my mathematics basically for my preparation during GATE exam. You guys can bookmark this channel. He teaches really well. I think he has very little subscribers as of now. He's a recent YouTuber. So, but I think the faculty whoever is teaching is doing exceptional job. So I would like you all, if you are preparing for GATE CS or GATE DA, to subscribe to this channel.
Thank you, Sumit.
Okay.
Thank you. We'll subscribe after the class.
Yes. So now let me come back to the. Okay. Now, so we are done with the polynomial arithmetic now. So next, now let us try to find. One second. What we can do in the remaining minute. Okay, I think we have almost covered up all the basics that we need to know.
Sumit,
Now let us.
Sumit, no need to wait till 12 o'clock. Can we ask some questions right away? Okay.
Yeah, you guys can ask right away.
And after that we can close. So my question is, what is the connection between AIML and linear algebra? Where exactly, at what point this will be used?
So in linear algebra, basically, so in AI, basically, this is what neural networks are. There are some values, there are some weights. These weights are multiplied with some other values, and then we get a final output. Okay, this is just a rough drawing of a neural network where we'll have multiple output. The weights will be multiplied, and then we'll finally get an output. So all this operation that's happening here is basically a linear algebra operation. So in these cases, we use large matrix will be of 1000 into 1000 matrix. Okay, such large computation will happen here. I think I can better visualize it to you guys. Give me a second. So 1 second. I think you guys can see the screen now, right?
Yes.
You guys can see the operation basically happening. So we have this matrix. So weight matrix is multiplying by input values, and then we are trying to find the activation value. So this operation is a matrix operation basically.
Wait a minute.
You guys can see.
To invoke this, are we supposed to write a Python function which will call this equation solving method, or what is it?
So generally, what we do is we do not write our code ourselves. Codes will be available to us. We just import it, and we just provide the input. We just provide the values. For example, input value v, the whatever we want. Just everything is taken care by the library that we're using. We can use libraries like PyTorch.
Okay, so
Or
what you are
TensorFlow,
saying
etc.
is the people who have written PyTorch would have used linear algebra to do the computation, is it?
Yes, yes. So,
Okay.
so basically, all this linear algebra operation that we are doing, it is done by the GPU. Okay.
GPU. Okay.
Okay. In order for GPU to do such matrix operation, we use something called as CUDA.
Okay.
This CUDA is a C++ library. Okay. And
Okay.
it is used to write the all these kernels.
Okay.
How the multiplication should happen, how should we do, how should I split it, and all of this is converted for easily. I also written is easily by PyTorch, TensorFlow, for even a non-coder to carry out, because all these are available in high-level languages such as Python. It is available.
So
TensorFlow is available in
can
JavaScript.
I
So
visualize it in the following way? At the extreme bottom layer is a C++ program. A
yes,
set of C++ programs are coming under what is called a CUDA library.
yes,
A further abstraction of the CUDA library is platforms like PyTorch or TensorFlow, and we
yes,
import these platforms in our Python user program to achieve some final end result.
yes,
Okay.
yes.
Okay. Okay. Fine. No, thanks a lot. Let me, before we close, I would like Shrestha and Vikrant to ask any questions. Yeah, do you have any final screen that you want to show? Sumit, the one which you showed there was fine. I'd like to stop the recording. Yeah, this is fine. Yeah,
Just a second, sir. I'm trying to find a better.
No, this is fine. I think I'll stop the recording. Okay.